Hello and welcome. Today we're diving into the invisible engineering that keeps Hong Kong standing. All around us, an unseen battle is being fought against gravity, especially during typhoon season. We're talking about slope reinforcement, the unsung hero of geotechnical engineering. In a city built on steep hills and battered by rain, keeping slopes stable is a matter of life, death, and billions in infrastructure. Every skyscraper, road, and hillside apartment relies on this hidden stability. Today we'll build a mini hillside, simulate a typhoon, and reveal 6 genius engineering tricks that keep Hong Kong from disaster. Let's get started. First up, soil nailing. These aren't your average nails. They're steel bars up to 20 meters long, drilled deep into unstable slopes. Crews drill holes, insert the nails, and pump in grout, gluing the nails to the soil and creating a reinforced skeleton. Imagine a loose stack of Jenga blocks. Now imagine dowels glued through them, turning chaos into stability. Soil nails bind weak soil, boosting its strength and preventing landslides. Let's demo our mini slope collapses under pressure, classic landslide. Now, with soil nails installed, the same force holds firm. The nails distribute the load, stopping failure before it starts. In Hong Kong's mid-levels, thousands of soil nails anchor slopes beneath dense apartment blocks. Those concrete pads you see on hillsides? They're the visible heads of these hidden guardians. Engineers use computer models to map out exactly where each nail goes, maximizing safety. The result slopes that withstand even the heaviest typhoons. It's a massive operation. Drill rigs, steel bars, and grout pumps working in harmony. Next time you see a hillside dotted with concrete squares, remember, it's not decoration, but a high-tech skeleton holding back tons of earth. Soil nailing is a simple idea, executed with precision, that tames nature's power. It's the reason so many of Hong Kong's steepest neighborhoods are still standing. Without it, the city's hillsides would be a constant threat. Soil nailing transforms dangerous slopes into safe, stable ground. It's a perfect example of engineering saving lives, quietly, invisibly, every day. The next time you drive past a reinforced slope, you'll know the secret beneath your wheels. Soil nailing, the silent strength behind Hong Kong's hills. It's not flashy, but it's absolutely essential. And it's just the beginning of the story. Let's move on to the next technique, rock bolting. Soil nailing is for dirt, but what about fractured rock? Enter rock bolting. Rock bolts are giant steel rods anchored deep into solid rock, clamping loose blocks to the stable core. Think of it as a super strong clamp, squeezing cracked rock together to prevent dangerous rock falls. Some bolts expand mechanically, others are grouted in place. Both create powerful compressive force. Our demo, a loose block collapses with a push. Add a rock bolt, tighten the nut, and it's rock solid. In Hong Kong, the Lion Rock Tunnel's granite slopes are secured with a grid of rock bolts. Each steel plate you see is the end of a hidden tendon holding the mountain together. Installation is precise. Geologists map every fracture, engineers design the bolt pattern, and crews drill and tension each bolt to spec. Rock bolts act like stitches, holding massive blocks in place and preventing catastrophic slides. They're essential for tunnels, highways, and anywhere fractured rock looms overhead. While soil nails reinforce loose earth, rock bolts clamp together the mountain's bones. Both are invisible, but both are vital for safety. Next time you spot a grid of steel plates on a rock face, you're looking at the frontline defense against rock falls. Rock bolting, simple, strong, and absolutely critical. It's another way engineers keep Hong Kong's steepest terrain safe, and it's just one piece of the puzzle. Now let's look at how we hold back entire hillsides from the outside. Retaining walls. Sometimes you need brute force, a retaining wall. These massive concrete or stone walls hold back tons of earth, resisting the outward push of a hillside. The key challenge? Water. Without drainage, hydrostatic pressure can topple even the strongest wall. That's why you'll see weep holes, small pipes that let water escape, relieving pressure and preventing failure. Demo time. A wall without drainage collapses under water load. Add weep holes, and the wall stands firm. Gabion walls, wire cages filled with rocks, offer a flexible, free-draining alternative. They blend into the landscape and handle ground movement without cracking. Gabions are often built from local stone, making them sustainable and visually appealing. Whether it's a concrete giant or a stack of rock-filled baskets, the principle is the same. Resist the Earth's relentless shove. Retaining walls are everywhere in Hong Kong, from highways to hiking trails. They're the visible face of slope engineering, standing guard against landslides. But their real strength comes from smart design, calculating forces, managing water, and choosing the right materials. Without proper drainage, even the best wall will fail. With it, these structures can last for generations. Retaining walls are the backbone of safe hillside development. They're a testament to the power of simple, robust engineering. And they're just one way we keep the city safe. Next, let's see how high-tech fabrics can make dirt stronger. Geosynthetics. Enter geosynthetics, engineered fabrics and grids that turn weak soil into a strong, stable mass. Geotextiles act as tough blankets, separating layers, filtering water, and preventing erosion. Geogrids are open mesh structures that add tensile strength, letting you build steep, stable slopes from ordinary soil. Demo loose sand collapses, but add geogrid layers, and the wall stands tall, mechanically stabilized earth in action. The grid interlocks with soil, creating a composite material far stronger than dirt alone. In Hong Kong, geogrids are used to build tall embankments quickly and cheaply, using local soil instead of expensive concrete. These hidden reinforcements allow for steeper, more resilient slopes. Geosynthetics are invisible once installed, but they're critical for modern construction. They combine material science and engineering to solve problems that concrete alone can't handle. The result: safer, more sustainable infrastructure. Geosynthetics are the secret weapon beneath our feet. They make the impossible possible, turning weak ground into a reliable foundation. And they're just one more way engineers outsmart gravity. But what if we could use nature itself to stabilize slopes? Let's talk bioengineering. What if we let nature do the work? That's bioengineering, using plants to anchor soil and prevent erosion. The star vegetation with deep, dense roots like vetiver grass, which forms a living net underground. Demo bare soil erodes instantly under rain, but grass-covered soil stays put. Roots hold everything together. In Hong Kong, hydroseeding sprays seeds and nutrients onto engineered slopes, jump-starting green cover for instant protection. Biodegradable mats made from coconut fiber or jute provide temporary stability while plants take root. Bioengineering is cost-effective, self-repairing, and boosts biodiversity. It turns sterile slopes into living ecosystems. For steep or high-risk slopes, it's combined with hard engineering, soil nails, walls, and drains for maximum safety. This hybrid approach blends strength and sustainability. Bioengineering is the green face of slope stability. It's not just strong, it's alive. And it's changing how we build with nature, not against it. But there's one more critical piece: drainage. Water is the #1 enemy of slope stability. Drainage is the ultimate defense. When soil gets saturated, it becomes heavy and slippery, increasing the risk of landslides. Poor water pressure acts like an air hockey table, reducing friction and making slopes unstable. The solution: get the water out. Surface drains, concrete channels, catch rain before it soaks in, directing it safely away. Subsurface drains, perforated pipes drilled into the slope, lower the groundwater level, reducing pressure from within. Demo open the drain valves, and the water table drops, instantly stabilizing the slope. In Hong Kong, thousands of slopes are fitted with drainage systems, especially in rain-prone areas like Sai Kung. After storms, these drains run for days, quietly keeping hillsides safe. Maintenance is key. Clearing debris and checking pipes ensures the system works when it's needed most. Drainage isn't flashy, but it's the most cost-effective way to prevent disaster. By simply giving water an escape route, we neutralize its destructive power. It's the unsung hero of slope engineering, and it's the final piece of the puzzle. 6 engineering techniques, often invisible, keep Hong Kong safe from landslides. From soil nails and rock bolts to geosynthetics, bioengineering, and drainage, each plays a vital role. In a world of extreme weather, this engineering is more critical than ever. It's about building resilient, sustainable cities that can withstand nature's fury. Next time you see a hillside, look for the signs of hidden engineering. Which method do you think fits your favorite slope? Let me know in the comments. Thanks for watching. See you in the next one.